Hello, and welcome to this section, Networked Game States. Now that we can host and join networked matches, it's time to start implementing the match logic that will control the flow of each map. In this section, we're going to tackle the player UI for displaying collected coins, current health, and the current power-up. We'll also implement the pause menu that will allow players to leave the game. We'll set up player tracking by implementing a players list which will allow players to see their scores compared to others in-game. We'll set up in-game states for managing whether we're waiting for players, starting the match, playing the match, or the match has ended. And we'll set up a waiting for players screen to enable players to select their characters and decide between joining as spectators or as players. We'll then set up a transition to the play state where we'll keep track of total match time, and then at the end we'll allow hosts to reset the match to waiting for players at will. So in this video, we'll start off by building our player UI. We'll be accomplishing this in 3 main steps. First, we're going to create a HUD for players that will display their current health, coins collected, and their selected power-up. We'll then create a custom player controller which will be shared between spectators and players to allow for a universal pause menu, and we'll also create a pause menu allowing players to leave the game or the host to restart the match. So let's get right into it. We'll start off by creating the widgets we'll need for our player HUD. In our widgets folder, we'll create a new folder called Player HUD, and within it, we'll create 2 new widget blueprints. We'll name them W_player_HUD and W_player_HUD_heart. We'll start by opening our W_player_HUD heart and simply place an image component with size 6464 and selecting the provided heart texture under the Appearance brush heading. That's all we need in here, so we'll compile, save, and close the blueprint. We'll then move on to our W_player_HUD and start creating everything we need in there. So first, we'll start in the Designer tab. We'll add an horizontal box, which we'll name Health Bar. We'll set size to content to true, and set it to be a variable so we can manipulate it from the graph. Next, we'll add another horizontal box, which we'll name Coins, and set it as variable. We set its anchor to the top right corner, position 0, 0, and set size to content to true, and its alignment to 1.1, 0. Within this horizontal box, we'll add an image. We'll set it to auto with horizontal and vertical alignment set to center, and as brush, we set the provided coin texture and give it an image size of 6464. We'll then add a spacer with size set to 10, X and 1 on Y, and follow it up with a text label with the text X and its font size set to 64. We'll then select our spacer and our text label and duplicate them and add them to the end of the horizontal box. We rename the second text label as CoinCountText, set its text to 0, and mark it as a variable for manipulation within the graph. And we'll finish off by adding a border that we'll name PowerUpBorder and mark it as a variable. We set its anchor in the bottom left corner. We'll set position to 64, minus 64, and its alignment to 0, 1. We set size to content to true, and then we move down to the Appearance heading where we'll set the Draw As property to border. Within this border, we're going to add an image component which we'll name PowerUpImage and set that as a variable as well. Under the Appearance heading, we'll set the image to no power-up and set the image size to 128, 128. We'll also set the tint to be half transparent. With that all done, we'll move over to our Graph tab and start wiring things together. We'll start by creating a new function called UpdateHUD. In our UpdateHUD function, we'll get the player controller and get its player state. We'll cast the player state to platformer player state, and if it's valid, we'll set the text of our coin count text to our number of coins collected. We'll then check that our selected power-up is not null by calling a isValidExec node. If it's valid, we set the brush from texture on our power-up image to the power-up icon, and if it's not valid, we set it to the no power-up texture. We also ensure that match size is unchecked. Finally, we check that the current health is not equal to the number of children of health bar, meaning the health has changed. If this condition is met, we clear the health bar of all children, and then we run a for loop where we create a W_player_HUD heart widget and add it to the health bar horizontal box. So with that done, we'll need one more function called hide HUD. This function will be for hiding the power-up, coin count, and health bar when not controlling a character. This function will take as input a boolean called b is hidden, and if b is hidden is true, we set visibility on coins, health bar, and power-up border to hidden. If b is hidden is false, we set visibility on all of those to visible. We'll move back to our event graph and over to our tick event. From here, we'll add a sequence to keep our code clean. From the then 0 pin, we'll get our player pawn and cast it to base character. If it fails, we call hide HUD with is hidden set to true. If it succeeds, we hide the HUD with is hidden set to false, and then call update HUD. And that's all we need to do in this widget for now. We'll compile, save, and close the blueprint. Let's get our HUD displaying in-game. For this, we're going to need to create a custom player controller. We'll create a new C++ class based on player controller, which we'll call platformer player controller. With our new class created, we'll navigate to Visual Studio, where we'll start defining our class. So, in our platformer player controller.h file, we'll need to add a couple of includes to give us access to the UMG widgets and our game instance enums. So at the top, before the .generated.h file, we're going to add include runtime UMG public umg.h, include blueprint /userWidget.h, and include platformer game instance.h. And then we'll start defining our class. We'll start by defining a constructor with a platformer player controller, and then we'll create a reference to hold our UMG HUD widget. So, uProperty, edit defaults only, blueprint read only, category equal, platformer player controller, T subclass of, class uUserWidget, C HUD. We'll then define our HUD instance with userWidget HUD, and then our virtual functions, virtual void setup input component override, virtual void tick float delta time override, and virtual void endplay endplay reason type reason override. So I'll define all my functions using IntelliSense and then move over to the CPP file and fill everything out. We'll start in our constructor where we'll simply enable the tick function with primary actor tick.beCanEverTick equal true. For our setup input component, right now we're just going to call our super, but we're going to return to it later. So super setup input component. And then in our tick function, we're going to ensure to display the HUD if we're in-game and destroy it if we leave the game. So we call our super tick delta time, and then we check to ensure that this is the locally owned controller with if is local controller. And then we get our game instance with uPlatformer game instance equal cast uPlatformer game instance get world get game instance. We ensure this was successful with if game instance, and then we check to make sure we're currently in game, where we if game instance get game state double equal e game state (e multiplayer in game. And if this is true, we create the HUD if it isn't already created. So if HUD equal null pointer, we ensure that we provided a HUD class with if chud, and then we create the HUD and add it to screen. HUD equal create widget user widget this, chud, and then HUD add to viewport. We then add an else if on our original game instance getGameState call, and if we're not in game and the HUD exists, so else if HUD not equal null pointer, HUD remove from viewport, HUD equal null pointer. Finally, we'll move to our endplay function and we'll ensure that we destroy the HUD if it exists. So we call our super endplay reason, and if the HUD exists, if HUD, we destroy it. HUD remove from viewport, HUD equal null pointer. So, at this point, we'll move back to our editor and recompile our project. Once compiled, we'll need to create a blueprint out of our Platformer Player Controller class. I named it BP Platformer Player Controller and placed it in our Assets Blueprint Game folder. Within it, we'll set our chud to w_player HUD widget, compile and save the blueprint. We'll then open our BP_game mode blueprint and change our player controller class to our newly created BP_platformer player controller blueprint. With that done, you can launch your game and see the HUD being displayed and updating accordingly as you pick up the various items. Before we continue, however, we'll quickly add a pause menu to our HUD so that players can finally leave the game and return to the main menu. So we'll start back in the editor and create a new widget blueprint called w_player_HUD_pause menu in our player HUD folder. We'll open that up, and within it, we'll place a vertical box with size to content to true, and within that box, we'll place a button called Leave Game, and on top of the button, we'll place a text label with the text Leave Game, with the minimum width set to 200 with text center justified. We then create an on-clicked event for our Leave Game button, and within it, we'll get our game instance, we'll cast it to platformer game instance, and then call Leave Game. You can compile, save, and close this blueprint now. We'll move back to Visual Studio to our platformer player controller.h file, where we'll define a boolean which tells us if the pause menu is being displayed. So, uProperty, blueprint read only, underscore, category equal platformer game instance, bool, bpause menu displayed. We'll also need two properties for keeping track of input state before going into the pause menu, ensuring we always release control appropriately. So, input mode, mode before pause, and bool, bShowCursor before pause. And finally, a function which will handle toggling the pause menu, so void toggle pause menu. We'll define the function with IntelliSense and move over to our CPP file. So in our constructor, we'll start by initializing pPause menu displayed, so bPause menu displayed equal false, and then in our setup input component function, we're going to set up the input binding for toggling the pause menu. So input component bind action pause menu, comma, input event IE underscore pressed, comma this, comma and a platformer player controller toggle pause menu. And finally, we'll implement our toggle pause menu function. What we're going to do is disable all game input while in the pause menu and retain the input state we were in before pausing, so we can restore it after leaving the menu. So bPause menu displayed equal not bPause menu displayed, and then we get our game instance, uPlatformer game instance equal cast, uPlatformer game instance, get world, get game instance. We'll then continue with if game instance, followed by if bPause menu displayed will retain the old input mode, so mode before pause equal game instance current input mode, followed by bShowCursor before pause equal game instance b is showing mouse cursor. And then we'll set the new input mode, game instance set input mode, input mode, UI in game, comma, true. We then add an else to our if pause menu displayed, so else we restore the old input mode, game instance set input mode, mode before pause, comma, bShowCursor before pause. We'll also need to go to our base character.cpp file and disable game input when the pause menu is displayed to ensure a clean UX. So at the top of the file, we're going to add include platformer player controller.h, and then we're going to add a platformer player controller PC equal cast a platformer player controller get world get first player controller, and followed by if PC and PC bPause menu displayed return. We're going to add this to the top of move forward, move right, rotate camera, change camera height, and use PowerUp Start Client. This will ensure that while the pause menu is displayed, none of the game functions will fire. And that is all we need to do in Visual Studio. We'll move back to the editor and compile the project. With the project compiled, we'll go back to our w_player HUD and display the pause menu when the boolean changes. So we'll start off by adding the pause menu to our Designer tab and anchor it in the center of the screen with position 00, alignment 0.5, 0.5, and size to content to true. We'll also set its visibility to hidden by default. We'll then move over to our Graph tab and create a new variable of type boolean with the name bPauseMenuShown. Now, from our then1 pin on our tick sequence, we'll get the player controller and cast it to platformer player controller. If it succeeds, we'll get the pause menu displayed and check if it is not equal to pause menu shown. If this is true, we set pause menu shown to pause menu displayed and show or hide our pause menu appropriately. You can compile, save, and close this blueprint now. Our last step will be to return to our Edit, Project Settings, and Input and change our Start menu to Pause menu, as I had misnamed that earlier in the project. With all that done, you can now launch your game in standalone mode and test everything out. Notice how we can join the game with 2 players and both players can monitor their health, coin counts, and power-ups independently. We're also able to press the Escape button on the keyboard or Start button on a controller to bring up the main menu and leave the game.